This video is on integration using residues. In today's video, we are going to evaluate the integral using residues. And now in this video, I am going to show that the integral I is equal to 0 to 2 pi 1 plus 4 cos theta by 17 plus 8 cos theta into d theta is equal to 0. See, for showing this, first we have to take z is equal to e power I theta. So we have to put z as e to the power of I theta. So what is e power I theta? So z is equal to, this is cos theta plus I sin theta. So if I take modulus on both sides, mod z is equal to modulus of cos theta plus I sin theta. So here if you see, mod z value is equal to, so mod z value is equal to root over, this value is cos square theta plus sin square theta, and therefore mod z value is equal to 1. So this is the region with circle with center 0 on radius 1. So this is the region, and the next thing here is we can write cos theta value as, so we need cos theta value and d theta value for substitution. So as we have z is equal to, see here, z value is equal to e power I theta, and see if I make a derivative on both sides, dz is equal to, for e power I theta it is again e power I theta, I into this is d theta. So this value is dz is equal to, this is zi into d theta. So d theta can be written as, this is dz by this value is z into I. D theta is equal to dz by this value is zi, and the next thing here is we need cos theta value. For cos theta, what we have to do, for cos theta this is e power I theta plus e power minus I theta by 2, and therefore cos theta is equal to z plus, this is 1 by z by 2, 1 by z by 2, and cos theta value is equal to, as we have e power I theta value as z, so this value is z, and this is z inverse which is equal to 1 by z. So if I take z as LCM, see here, this will be z square plus 1 by 2, and therefore cos theta value is equal to, cos theta is clearly z square plus 1 by 2z. So we got all the values ready for substitution here. That is, we got the region as a circle with center 0 on radius 1. We got the value of d theta and again cos theta. Now I am going to substitute in the given integrals. So first thing here is we got mod z value is equal to 1. The first thing is mod z value is equal to 1. The next d theta value is also ready as d theta is equal to, this is dz by z into I, and the next cos theta value here is z square plus 1 by, so this is z square plus 1 by, this value is 2z. Now I am going to substitute in this integral. So the integral value here is, this is integral 0 to 2 pi. So this value is integral 0 to 2 pi, that is 1 plus 4 cos theta. 1 plus 4 cos theta by, this is 17 plus 8 cos theta. So 8 cos theta into d theta. So this can be written as integral 0 to 2 pi. This is 1 plus 4 times of cos theta. What is cos theta value here? This value is nothing but z square plus 1 by 2z by, and here this is a 17 plus 8 times of again cos theta. Cos theta value is nothing but z square plus 1 by 2z into d theta. So what is d theta value here? This is dz by, this value is z into I. This value is z into I. So this can be written as integral 0 to 2 pi. So if I take 2z LCM in the numerator, this will be 2z plus, this value is 4 times of z square plus 1. Clear? And next thing here is, if I take 2z as LCM in the denominator, this will be 17 2z, this is 34z plus 8 times of, this is z square plus 1 into here, this value is dz by z into I. Clear? I can cancel these two, and see, after multiplying what happens here, this will be 0 to 2 pi. So this value is 2z plus 4z square plus 4 by, this value is 34z plus, this is 8z square plus 8 ones are 8 into, this is dz by zi. So if I write it in a proper way, so that is integral 0 to 2 pi, this can be written as 4z square plus this is 2z plus 4 by here this will be 8z square plus this value is 34z plus 8 into this is dz by this value is zi. So if I take 2 LCM in the numerator, so this is if I take 2 LCM, this will be 2z square plus z plus 2 by here if I take 2 LCM here, this will be 4z square plus 17z plus 4 into this value is dz by z into I. Clear? So this is integral 0 to 2 pi. This value is 2z square plus z plus 2 by this is z into I into this value is 4z square plus 17z plus 4 into here the value here is dz. So what is our f of z value? Integral f of z into dz. Now I am going to take this f of z value. So f of z value is very clear as this is 2z square plus z plus 2 by this value is I into z times of this is 4z square plus 17z plus 4. Clear? So we need the poles for the given equation. So in order to find the poles, for this equation, what is our f of z value? So f of z value is nothing but this value is 2z square plus z plus 2 by this is I times of z into this value is 4z square plus 17z plus 4. Clear? Now if I want the poles, what I have to do, I have to equate the denominator to 0. So if I equate this denominator to 0, this will be I into z times of this is 4z square plus 17z plus 4 is equal to 0. So in this case z is equal to 0 and next one this value is 4z square plus 17z plus 4 is equal to 0. See here 4 is 16. So this can be written as 4z square. 16 ones are 16 and 16 plus 1 is 17. So 17 can be written as 16 plus 1 plus 4 is equal to 0. So if I take 4z common, so this will be z plus 4. And here if I take 1 common, this will be z plus 4 again. See clear? So if I take z plus 4 common, so this will be 4z plus 1 is equal to 0. Now here z is equal to 0 is a simple pole and here if I equate z plus 4 to 0, then z is equal to minus 4 and here 4z plus 1 is equal to 0 if I equate, then 4z is equal to minus 1 and z value is equal to minus 1 by 4. And here the region I have shown you. First thing here, the region is a circle with center 0 and radius 1. So let us go through it. So the region here is mod z is equal to 1. So this is a circle with center 0 and radius 1. So this is minus 1, this is I and this is minus I. Here if you see 0 is within the region and here minus 1 by 4 minus 0.25. So here this is minus 1 by 4 is also within the region and minus 4 here it will be minus 4. So this is minus 2 minus 3 minus 4. So this is outside the region. So we need the residue values for the corresponding poles. Z is equal to 0 and z is equal to minus 1 by 4 and this value is outside the given region. Now let's get started to find the residue values for this. So first one f of z is nothing but, so f of z can be written as, so what is this f of z? So this value is, see here, this value is 2z square plus z plus 2 plus I times of, see here this is I times of z into here after splitting this, so this is z plus 4 into the value here is 4z plus 1. See here these are the factors. One is z and z plus 4 into 4z plus 1. These are the factors. Now we need the residue values for this. So for finding the residue values, which are simple here, simple poles, the residue of f of z at z is equal to 0 is nothing but this is limit z tends to 0. This value is z minus 0 into f of z. Clear? So if I substitute the same thing here, then this will be limit z tends to 0. So this is limit z tends to 0 z minus 0 into f of z. So this value is f of z, which is equal to 2z square plus 2z square plus z plus 2 by this is I times of z into this is z plus 4 into this value is 4z plus 1. So if I cancel z minus 0 and z and substitute in place of z as 0, so here the numerator is 2 and I times of this is 4 and this is 1. So if I cancel, so the value here is 1 by 2i. See clear? So the pole value, the residue value for the corresponding pole, interior pole, z is equal to 0 is 1 by 2i. So this value is I. So at point 0, we got the residue value. And next minus 1 by 4 is inside. So inside the region. Now I am going to find out the residue value for that. So for finding the residue value of f of z, residue of f of z at pole value z is equal to minus 4 is, this is limit z tends to minus 1 by 4, this is z plus 1 by 4 into f of z. Clear? And now see here, this value will be limit z tends to minus 1 by 4. So this is limit z tends to minus 1 by 4. This is z plus 1 by 4 into f of z. So what is our f of z value? So f of z value is this one. That is 2z square. Here is f of z value. That is 2z square plus z plus 2 by I times of z into this is z plus 4 into this is 4z plus 1. Clear? And now see here, this will be limit z tends to minus 1 by 4. This is z plus 1 by 4. This value is 2z square plus z plus 2 by I into z into this is z plus 4. If I take 4 common from this will be z plus 1 by 4. Now I'll cancel these two and substitute in place of z as minus 1 by 4. This is 2 into, in place of z I'm going to substitute minus 1 by 4. So this is also minus 1 by 4 plus 2 by I times of this is minus 1 by 4 and this is minus 1 by 4 plus 4 into 4. Clear? This is 2 times of 1 by 4 into 1 by 4 is this is 1 by 16. Clear? So this is minus 1 by 4 plus 2 by here this value is I times of, here I can cancel these two. This is minus 1 into minus 1 plus 16 by 4. If I cancel these two 8 times, so this will be 1 by 8 minus 1 by 4 plus 2. This is minus I times of this is 15 by 4. So here if I take 8 as LCM, this will be minus 1 plus 2 plus this value is 16 by this is minus I into 15 by 4. This is 17 minus 2 which is equal to this is 15 by 8. If I send it to the numerator, this will be 4 by 15 into this value is minus I. So now I can cancel these two and answer here is minus 1 by 2i. So this is the residue value of f of z at z is equal to minus 4, minus 1 by 4. So we got the residue values of z is at the pole z is equal to 0 and z is equal to this is minus 1 by 4. Now we have to apply. So which thing we have to apply? The residue theorem we have to apply. So here according to our residue theorem, our residue theorem states that integral f of z into dz is nothing but this is 2 pi I times of this is sum of the residues. This is a sum of the residues at interior poles. So here the interior poles are 0 and minus 1 by 4. Now what is our f of z? So f of z is nothing but the question, that is integral 0 to 2 pi 1 plus 4 cos theta by this is 17 plus 8 cos theta into d theta is equal to 2 pi I into sum of the residues. The first residue value here is, the first residue value at z is equal to 0. See here, the residue value is 1 by 2i. At z is equal to 0 interior point, it is 1 by 2i. At the next interior whole, that is minus 1 by 4, the value here is minus 1 by 2i. So this value is minus 1 by 2i. So if I cancel these two, that is 2 pi I into 0, the value here is 0. And therefore, the thing here is we got, therefore integral 0 to 2 pi, that is 1 plus 4 cos theta by, this is 17 plus 18 cos theta into d theta value is equal to 0. So this value is theta is equal to 0. So this is how we have to solve. So using a residue theorem, the value here is 0. So this is what it is asked to show that. So let me explain you once again. See, the first step here I have taken here is, so I is equal to integral 0 to 2 pi 1 plus 4 cos theta by 17 plus 8 cos theta d theta is equal to 0. The first thing here we have to take is z is equal to e power I theta. So this is nothing but cos theta plus I sin theta after applying modulus on both sides. So we got the region with center 0, circle with center 0 and radius 1. And next thing here is we need d theta value. For d theta also, after making derivative on both sides, we got d theta value, and cos theta value is also ready as usual. So here the next step is, so we have to apply in this integral all the three values here. So in place of cos theta as z square plus 1 by 2z, dz value as dz by zi. So we got f of z value as this one. So we know that if we equate the denominator to 0, we'll be getting the poles of the given function. So I have equated the denominator to 0 and I got three poles, one as 0, one as minus 4 and one as minus 1 by 4. So as we have a region with circle with center 0 and radius 1, so 0 is inside the region and minus 1 by 4 is also inside the region and minus 4 is outside the region. Therefore, there is no need of finding the residue for this function, and we have to find the residues for the interior poles. So first pole is z is equal to 0. As it is a simple pole, the formula is also simple. F of z is also very clear here after splitting into factors. See here, we got the residue value of f of z. The interior pole z is equal to 0 is 1 by 2i, and the next interior pole is minus 1 by 4. So this is also an interior pole, and here after substituting and calculating, see here this is minus 1 by 2i. Now after getting the residue values, we have to apply the residue theorem. Residue theorem states that integral f of z dz is nothing but 2 pi I into sum of the residues of the interior poles. The first pole value, residue value is 1 by 2i, and the second pole residue value here is minus 1 by 2i. So this is 0, and finally we got 0. This is what it is asked to show that, and hope you all guys understand. If you really understand, please practice definitely. It is the most important questions. There are few more questions which are to be uploaded. I'll be uploading very soon, and see, watch the playlist once. So many videos are uploaded for your preparation. Please avail those and get your score more, and please pass it on to your friends. Subscribe to this channel and stay connected. Thank you so much.